Hello and welcome to another video. In this video we're going to be working on sorted array by parity. So in this problem you're given an integer array nums and you want to move all the even integers to the beginning followed by the odd integers. And you want to return an array that satisfies this condition. So for the example 3, 1, 2, 4, any array where your even integers are beforehand work and any one of these is fine. And for the second example we have num0 which returns 0. So obviously there is like the super easy way of doing it, right? Where you just have your array and you do a two-pass solution where you just do in your first pass any even number you just put into your output, right? So you would just traverse, you'd say not even, not even, even, let's throw that into our output, even, let's throw that into our output. And then the second pass would do the odds, right? So you would get an odd, then you'd get an odd here. So that's like a really easy way of doing it, not going to discuss that much. We're going to do an in-place solution, which is a little bit tougher, and it's a little bit, at least for an easy problem, there's something to talk about. So let's just get a bunch of numbers and kind of show you how this works. So essentially, just have some numbers like 2, 8, 3, 4. Maybe let's have more even numbers or more odd numbers like 2, 5, 3, 4, and then we'll have like 1. Like some odd or something, right? 9. Yeah, let's just have like 7, 2, 4 again, or something like that. That doesn't really matter. It's good enough. Okay. So essentially, all we need to do is make sure that the even numbers are on the left, right? We don't really care about the order. We just have to make sure they're on the left. So what we're going to do is we're just going to make 2 pointers. So we're going to make a pointer here and a pointer here. And there's going to be a couple scenarios, right? So there's going to be actually 4 scenarios. Like, what are all the scenarios? And let's go over them. So scenario of 1, we have the left is even and the right is even. So what would we want to do there, right? If they're both even. So if the left is even and the right is even, the left is fine and the right is not, right? So what we're actually going to want to do is this is fine, this is not. We're going to want to replace this later. But for now, we're just going to move up this left pointer up 1. So we're going to say, let's just move the left pointer up 1. We can't really do any swaps. Okay, now what if we have even and then odd? Well, if we have even and odd, that's what we want, right? So if we have even and odd, then like we don't need to do any swaps. So these elements are fine and we just move them both. So then we just have left plus 1 and right minus 1, right? Then what if we have odd, even? So if we have odd and even, then we want to essentially swap, right? Because we want the evens to be on the left, and we want the odds to be on the right. So this is going to be a swap. And then finally, if we have odd, odd. So if we have odd, odd, the right is fine, and the left is not. So anytime something's fine, we can just move the pointer to the next one, because this is fine, right? So this is going to be right minus 1. So let's just use this logic to go through it, and then we can figure out how we can simplify this logic a little bit. So essentially, we're going to look what state do we have. So we have an even and an even. So our left is fine, our right is not. So essentially, we're just going to move up this left to the right, right? We're going to move it up over here because this one's fine, or sorry, this one's fine. So we can just move this up, but we need to leave this because we're going to want to have a swap. Okay, now we have an odd and an even. So it looks like we want to swap, right? And that is the case. We do want to swap because we want our evens to be before the odds. So we're going to swap the 5 and the 4. And we're going to have a 4 here. Whoops. Don't know what that is. So we're going to have 4 here, 5 here. Okay, now what case do we have? So now we have even odd, which is like perfect, right? So these are both fine, so now we need to move both of these just up. So let's just move both of these to the next one, essentially. So we're going to move this over here, this over here. Now we have odd even, so we are going to want to swap. So we're going to have this, and we're going to have 2, 3. Now they are fine. So notice, by the way, every time we swap, then they're going to be fine in the next iteration, and we can actually move these. We can move these up. So that's going to be important to like note. Like whenever you swap, these will always be a valid index, and in the next iteration, we're just going to move them towards each other because they're going to be fine, right? So we have even, odd. So these are fine. This is what we want, right? We want the evens to be before the odds. So let me actually just double check where I was. Okay, there we go. So we're on the 3 and the 2. So now we will be over here. Okay. Now we have even, odd, which is what we want again. So we just move these towards each other one more time. Okay. And now they are over here. And now we have odd, odd. So odd, odd, we move this right one to the left because this one, is that correct? Yeah. Because this one is not fine, right? We want the left to ideally have evens and the right to have odds. So this is fine. So then we're going to move the right over here. And now finally we end up here and we break because the left is no longer less than the odd, or the right. And now if we actually take a look, we have our evens and then we have our odds. So it all worked out. But let's try to simplify this a little bit, right? So notice every time we make a swap, in the next iteration, like if we make a swap from odd to even, it's going to switch to even, odd. And for even, odd, if you take a look, then you just move them. So instead of doing this, we can actually simplify this to this. So we can check for even, odd. And if it's even, odd, then we make a swap. But regardless of if it is or if it isn't, now we can see if we can move these up, right? So what we can do is if they're even, odd, let's make a swap. But then let's check for the left being even. And if the left is even, we'll move the left up. And let's check for the right being odd. And if it is, let's move the right down. So we can actually condense into these things right here. So if it's even, odd, we make a swap. And then we just proceed to this. So if the left is essentially fine, we move the left up. And if the right is fine, we move the right down. And now we condense our 4 steps into just this right here. So we just check for a swap. If we can make a swap, fine. And if we can move one of them, we'll move one of them. And we're guaranteed to be able to move at least one of them, because if we couldn't move one of them, then we would do a swap, right? Because if it's not even, odd, any other combination, at least one of these is true. Like for even, the left is true. For odd, even, odd, even is a swap. So it's actually even, odd isn't the swap, it's odd, even, right? So we screwed that up a little bit. So this should be odd, even. There we go. So now, if it's even, this will be true. If it's even, odd, this will be true. If it's odd, even, we will swap. And if it's odd, odd, then this will be true. So basically, you're either moving one of these, or you're swapping, or you're doing both, and you're essentially condensing your code. And if you follow this, you can do an in-place swap. So it works out quite nicely. So this is essentially all we need to code up. We're just going to start at the left and the right, and we're just going to check, do we need to make a swap? And are the elements fine? If they are, let's just move those accordingly. We can move both of them in the same iteration as well. So let's code that up now. So I actually did do this earlier, but let's take a look. Okay, so essentially we're going to make a left and a right. And we're going to make those 0 and length nums -1, right? Then we are, like I said, we're just doing this until the left is no longer less than the right. So first we need to check for the swap, right? And let's go back to what we want. So for the swap, we want odd and then even. So for odd and then even, there's a few ways to write this, but essentially odd and then even means that nums L mod 2 is 1, and then nums R mod 2, and there's a bunch of ways to write this, like I said. So this is just one of the ways. So this has to be 1, and this has to be 0 for this to be true. So we can just check for greater than, and then that would do it. So if this is the case, then this is odd and this is even. So then we want to swap. So we can just say, because it's Python, we have a lot of easy ways to swap, right? So we can just do this. Nums R, nums L, we swap in place. And now we want to check, remember, we want to check if the left is even. And if the left is even, we move the left up. So let's do that. So if nums left mod 2, and like I said, you can do this, or you could do not nums L mod 2, a bunch of ways. So if this is even, then we will move the left up. And if the right side is odd, so if this is true, that means the right side is odd, then we will move the right down. And that's pretty much it. And then we finally return the numbers. So this does the swap. This moves the left, this moves the right, and then you do this until you're out of bounds and you're guaranteed to get an answer in place here. And let's run that. Looks like it's good. And let's submit. And it's all over the place for this again, because I'm sure people have like the same solution, so it's just like whatever. Let's wait until we get a good one. Maybe it might take too long. Okay, well, not working too well. But eventually you get a good solution if you just keep clicking long enough. But anyway, regardless, let's think about the time and space. Okay, I give up. Because like I said, this is like, everyone has pretty much the same solution here, so it's kind of hard to stand out. So for the time and the space, let's think about it, essentially. So we are looping through our array, right? And we're basically either going to be doing a swap or moving them up or both. So worst case scenario, you know, you might have to like do a swap and then move something up. So worst case, it's like 2 times n or something, but essentially this is n time. And for the space, since we're doing it in place, it's O of 1. But also you can argue that, you know, if you just make a result array and go through your nums, if you don't count the result as part of the space, you could argue that's the case. But I would think for this, at least if I was given this problem in an interview, I would think like they'd probably want to have an in-place solution, because I think this, if it's not an in-place solution, it's like insanely easy, right? You literally just do a 1 pass, check for evens, and then check for odds, and then just push the array. Like that would just take like 5 seconds to code. But I mean, you might get asked that, so you never know. In either case, so that's going to be it for this problem. So hopefully you did like the solution. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.